In our introduction to Chapter 3, we talked about inequalities, how to read them, how to graph them, and how to name them from a number line that already were graphed. We then went into a little discussion about solving one-step inequalities that involved addition and subtraction. Here's just a couple of quick problems for us to refresh our memory on our last session. Think about that one inverse operation that you need to use in order to isolate your variable. If I'm looking at this first one, I see I have 3 plus x, so the inverse of this 3, or in order to eliminate this 3, I will subtract 3 on both sides. That will give me x is greater than -1. Now, when we write an inequality, the variable should always come first, so that this way our graph is correct. We'll find -1 on the number line, and you should recall that that's an open circle because it does not include -1. And we'll shade everything in the greater than direction. Now on to our second problem. You might notice right away that the variable's on the right and not the left, so that means at the very end we're going to do the interchange. We see x plus 6, so we will subtract 6 on both sides. That gives me 3 is greater than or equal to x. With the interchange, I get x is less than or equal to 3. I find 3 on my number line. This time it's a closed circle. That means that 3 is a possible solution to this inequality. And I shade everything in the less than direction. Third one, let's do the inverse addition property of inequality. So let's add 2 on both sides, and I'll get x is less than -1. Open circle and shading. Okay, so that was where our one-step add subtract. So as you might expect, we're going to go on to multiply and divide in today's lesson. In lesson 3.3, we're going to be solving inequalities using multiplication and division properties of inequalities. Whatever we do on the left, we'll do on the right. We take this first one and we see 4 times x, which is multiplication. We'll divide both sides by 4. Our solution will be x is all real numbers that are greater than -4. And again, I'm articulating the solution. X is all real numbers greater than -4. Going on to the one to the right, I see 3 times x, so I'll divide both sides by 3. X is now less than or equal to 16. This would be a closed circle and shading to the left. X is equal to all real numbers less than or equal to 16. And the next problem is a division. X divided by 3, so the inverse will tell me to multiply. Whatever I do on one side, I do on the other to keep the balance of this inequality. X is going to be less than 18. So all real numbers less than 18, but not including. One more here. We'll multiply by 4. And we'll see that x is all real numbers greater than -16. Open circle and shading. Now there's always something to be careful for or mindful of, and that this time is when you multiply or divide by a negative. Multiplying or dividing each side of an inequality by a negative changes the meaning of the inequality. So you need to reverse the direction of the inequality symbol to make this inequality true. Let's take a look. Let's consider the following. Here's a true statement. 3 is greater than 1. Well, let's suppose we multiply both sides by -2. So I'm then going to simplify. -2 times 3 is -6, and -2 times 1 is -2. When I look at this inequality now, I see that -6 is less than -2. So by multiplying by a negative, and the same would be true of division, it reverses the directions of the symbol. So again, when I simplify and I compare, I notice that the inequality must be reversed in order to make that a true statement. We're now going to apply that to our solvings. Here's that rule again. You must reverse the inequality symbol to make the statement true when you're multiplying or dividing by a negative. Again, it doesn't matter if the number on the opposite side is negative. What matters is what's attached to the variable. I'm going to be dividing both sides by a -3, so that gives me x is going to be less than -5. In my next one, this is a division. I will multiply both sides by -2. As soon as I hear I'm multiplying or dividing by a negative, it tells me to reverse the direction of my inequalities. It's one of those rules that you really have to commit to memory. People tend to forget, and I think if you practice enough, you'll keep it in mind. So now one last thing I want to talk about is deciding whether a number is a solution to an inequality. Now, a solution is any number that makes that statement true. So we're going to be identifying by evaluating. We're not going to solve. And we've done this before with equations. Let's take this inequality, 2x plus 1 is greater than -3, and let's replace x with -3. 2 times -3 plus 1 is greater than -3. I wonder if I simplify if that makes a true statement. I've got -6 plus 1. And then when I simplify this, I have -5 is greater than -3. Well, -5 is less than -3, so -3 is not a solution. On to our second problem. You're using the same inequality. 2 times -1 plus 1, is that greater than -3? Well, -2 plus 1 will give me -1. And -1 is greater than -3, so -1 is a solution. Now, there's one thing we should be careful of, is that less than or less than or equal to symbol. There'll be times when we'll be given a number to test out. Suppose we had 4x minus 1 is, well, let's just change this to start with. Let's make this greater than, let's say 15. Okay, let's test out and see let's see what number we're going to test. Is 4 a solution? All right, so let's substitute it in. We're evaluating. 4 times 4 minus 1, is that greater than 15? Well, 16 minus 1 is 15. But if you read this statement, it is a false statement. 15 is not greater than 15, so 4 is not a solution. Had there been a line underneath, the answer would have been true. So we're going to take a look at determining whether numbers are possible solutions. We're going to do a little practice, and next class we'll work on the multi-steps.